Hello everyone, welcome to the 2025 AMC 8 problems. Today I'm going to go through problems 1 through 10. For the next 4 videos, I'm going to do the entire set, so let's just get into it. Problem 1. The 8-pointed star shown in the figure below is a popular quilting pattern. What percent of the entire 4x4 grid is covered by the star? So we want to find the shaded over the total area. So the total is going to be 16. And the shaded, we can just count them. This is 1, 2, 3, 4. And we can combine these into 1. 1, 2, 3, 4. So we have an area of 4 in the middle section and another 4 in these tips here, like these stars combined into 1. So that would be 8. So 8 over 16 expressed as a percent is, it's just going to be 50%. So the answer is B. Problem 2. The table below shows the ancient Egyptian hieroglyphics that were used to represent different numbers. For example, 32 is represented by this. What number is represented by the following combination? Well, we have a 10,000. 4 of these symbols is 4 times 100. 2 of these symbols is 2 times 10. 3 of these symbols is 3 times 1. So if you add these up, you get 1. There's nothing in the thousands. 4, 2, 3. So the answer is B. Problem 3. Buffalo Shuffle is a card game in which all the cards are evenly distributed among all the players at the start of the game. When Anika and 3 of her friends play Buffalo Shuffle, each player's dealt 15 cards. Suppose 2 more friends join the next game. How many cards will be dealt to each player? So Anika and 3 of her friends is 4 people in total. 4 people, each is dealt 15 cards. So in total, this is 60 cards. If 2 more friends join, then the 4 will become 6. And 60 evenly distributed into 6 parts is going to have 10 in each part. So the answer is C. Problem 4. Lucius is counting backwards by 7s. His first 3 numbers are 100, 93, and 86. What is his 10th number? So his first number is this, second is this, third is this. Each time you count down, you subtract 7, obviously, and you want to get to 10. You want to find this number. So going from 1 to 10, it takes 9 steps. 10 minus 1 is 9. And each step goes down by 7. So you subtract 7 from 100 9 times, which is the same as 100 minus 7 times 9 equals 100 minus 63 equals 37. So his 10th number is B, 37. Betty drives a truck to deliver packages in a neighborhood whose street map is shown below. She starts at the factory F and drives to location A, then B, then C before returning to F. What's the shortest distance she can drive to complete the route? So this looks like instead of going the shortest straight line path, we have to follow these lines. So for this, we can consider each destination separately, because you have to go from F to A to B to C back to F. So from F to A, you just have a rectangle. You start from here and then go here. I'm shading this so you can see it better. So this is the path from F to A, and then A to B is like this. B to C is like this, and C back to F is once again this. Any path, any rectangular path, even like this, is gonna have the same length because they have the same number of left steps and right steps. So we just want to find the total length of this entire thing. We can, instead of considering this, or instead of considering this path here, let's just move it to here. It's the same length, but it'll be easier to calculate. Now we're just trying to find the perimeter of this big rectangle, and that is a length of 1, 2, 3, 4, 5, 6, 7, 7 by 1, 2, 3, 4, 5, 7 by 5 rectangle. So the total perimeter is 7 plus 5 times 2. 12 times 2 is 24. So the answer is C. Problem 6. Siku writes down the numbers 15, 16, 17, 18, 19. After he erases one of the numbers, the sum of his remaining numbers is a multiple of 4. Which number did he erase? So the total, we want to, the sum of the 4 remaining numbers is the total of this minus the number that he erased. So this is a multiple of 4. The total can easily be calculated. 15, 16, 17, 18, 19 is an arithmetic sequence, and we know that the sum of an arithmetic sequence is the middle number times the number of numbers. The middle is 17. There are 5 numbers, so the total is 85. 85, when divided by 4, has a remainder of 1. And every multiple of 4 has a remainder of 0 by definition. Has a remainder of 0 by definition. So this number here is also going to have a remainder of 1. So we want to find a number that's a remainder of 1, and in these 5 numbers, only 17 has a remainder of 1. So the answer is 17. In more formal mathematics, we call this modular arithmetic. So we say 85 is 1 mod 4. This multiple of 4 is 0 mod 4. And 17 is also 1 mod 4. Problem 7. On the most recent exam on Professor this guy's class, 5 students score at least 95%, 13 scored at least 90%, 27 scored at least 85, and 50 scored at least 80. How many students earned a score at least 80 and less than 90? So between 80 and 90. So let's just make like kind of a diagram. This is like a number line of all the scores. So 80, 85, 90, 95, 100. 5 students are in this region. 13 are in this region. 27 are in this region. And 50 are in this region. So we're asked to find the total number in this region right here. Oops. This region. So to find that, we just take 50 minus 13. And anything that's not in 13 is going to be in 50. So the answer is just 50 minus 13 equals 37. The answer is D. Problem 8. Isaiah cuts open a cardboard cube along some of its edges to form the flat shape on the right, which has an area of 18 square centimeters. What is the volume of the cube in centimeters? So a cube is going to have 6 sides, 6 square sides, and if the total has 18, then we want to divide by 6 to find that each square is an area of 3. The area of 3 can be used to find the side length. S squared, side length squared is the area. So S equals square root of 3. And we want to find the volume of the cube. The volume of a cube is just S cubed. So that's just cube root of 3 cubed, which I'll just explain this. It's just square root of 3 squared times square root of 3, which is just 3 times square root of 3, which is A. Problem 9. Ning Li looks at the 6 pairs of numbers directly across from each other on a clock. She takes the average of each pair of numbers. What's the average of the resulting 6 numbers? So, based on the diagram, let's just write something out. So if we do 1 and 7, the average is 1 plus 7 over 2. And then 2 plus 8 over 2, dot, 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 until 6 plus 12 over 2. And we want to find the average of these 6 numbers. So again, we add these up and divide by the number of numbers, which is 6. But this is just the same as adding these 12 numbers up, dot, 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 6, 12. So you're just dividing by 12 at the end. So this expression just becomes the sum of the numbers from 1 to 12. We divide by 2, and then we divide by 6. So the total is going to be divided by 12. And we know the sum of an arithmetic sequence is the middle. In this case, it's going to be 6.5 times the number of numbers, 12. If you divide by 12, these cancel out. So the answer is 6.5. B. Problem 9. In the figure below, ABCD is a rectangle with sides of length AB and sides of length AB equals 5, AD equals 3. It is rotated by 90 degrees along the midpoint of DC to give a second rectangle. What's the total area of the overlap of the two rectangles? Let's just draw a diagram first. Try to match it to the diagram as close as possible. We don't need the letters. So the overlap or the union is just the total sum of the two areas, which is going to be 2 times 5 times 3. This is the area of one rectangle, minus the intersection, which is this region, intersection. So we just want to find the intersection of this. We know this is 3 and this is 5. So the midpoint of this would cut this into two segments of length 2.5. So by symmetry, this rectangle is going to be a square because it's symmetric along this line right here. So there's no reason for this rectangle to not be a square. So this is also going to be 2.5. The area of this is going to be 6.25. It's 2.5 squared. So the total is 30 minus 6.25, do some math, you get 23.75. So the answer is D. All right, thank you guys for watching problems 1 through 10. I'll see you in the next one.